In this video we're going to look at how to solve problems involving maximum and minimum points. This is a practical use of differentiation. So we're told a water tank will be made from 54 meters squared of metal, and the tank's going to form a cuboid with no top, and the height and width are both x meters and the length is y meters. Show the volume is given by v equals 18x minus 2/3 x cubed, and find the maximum volume. Well, let's do a little sketch to start with. So I've got a cuboid. Okay, and I'm going to be able to see part of this as well because it's got no top. So I'm just going to shade the opposite sides there. In fact, we'll be able to see a bit more than that. Okay, so height x, width x, length y. So the amount of metal that is required is 54, and that's to create these 5 faces. So I've got 2 faces that are x by x, and 3 faces that are x by y. So that gives me an equation involving x and y for the surface area. And then I'm going to consider the volume. So the volume is given by x squared y, so x times y. But I need an expression for the volume that does not involve y, because the one given in the question, which I'm asked to show, did not have a y. So how am I going to eliminate that? Well, I'm going to take it from here. So I'm going to subtract 2x squared from both sides, and then I'm going to divide through by 3x. So y is 54 over 3x minus 2x squared over 3x, and that simplifies to 18 over x minus 2/3 of x. And now I'm going to substitute that into my expression for v. So v is x squared lots of 18 over x minus 2/3 x, which is then 18x minus 2/3 x cubed, which is what I was asked to show. So from this point I can now deal with the second part of the question, which is to find the maximum volume. Now they like to ask you these questions in stages, so if you mess up the first bit you can still work on the second bit. So I'm going to find the maximum volume. So a maximum occurs where the gradient is 0. So dv by dx. I'm going to differentiate this value for v here, so that gives me 18 minus 2x squared, and that's going to have to be equal to 0 where there's a turning point, so where there's a maximum or a minimum. And I can solve that to give me x is positive or negative 3. But because I'm dealing with the length, the value x equals negative 3 doesn't make sense in this context, so I'm going to just ignore it. So where x equals 3 is where I have my maximum value. I could differentiate this again and show that this is a maximum, because I would show that the second derivative is less than 0, but it tells us in the question it's a maximum, so I can actually just skip that. Okay, so v is 18 multiplied by 3, subtract 2/3 of 3 cubed. So let's evaluate that on the calculator. So 18 multiplied by 3, subtract 2/3 times 3 cubed, gives me 36. So my maximum volume is 36 meters cubed.